Welcome to Ababil Math World. Today I'm going to simplify and get the value of a very interesting problem containing factorials. So you can just see it. It is 3 by 1 factorial plus 2 factorial plus 3 factorial plus 4 by 2 factorial plus 3 factorial plus 4 factorial and so on up to 25 2025 by 2023 factorial plus 2024 factorial plus 2025 factorial. This sum I have to calculate. So now before I could calculate the sum, you can see that what is the pattern present here. So this number and this factorial is same. This number and this factorial is same. And in the last term, this number and this factorial is same. What is the number before this? 1 less than this and its factorial. 1 less than this and its factorial. Similarly 4, 1 less than 4, 3, its factorial. 1 less than 3, 2, its factorial. So 3, 2 factorial, 1 factorial. So now here, if it is n, it is n plus 1, it is n plus 2, and here it is n plus 2. This is the idea. So that means the nth term of this equation, this expression is the nth term. The nth term of this is in the denominator. I have to start with this. It is easy for me to make assumptions. So n factorial plus n plus 2 factorial plus n plus 3 factorial, the same n plus 2. So n plus 1, n plus 2. So here it is n plus 2 divided by n factorial plus n plus 1 factorial plus n plus 2 factorial. This is actually given in terms of factorial. I simplify it. N plus 2 divided by, this is n factorial plus, and this can be written as n plus 1 times n factorial plus, this is n plus 2 times n plus 1 times n factorial. So here, this is equal to n plus 2 times, in the denominator n factorial, n factorial, n factorial is common. So I can write n factorial times, this is 1 plus, and here I have only n plus 1 plus, it is n plus 2 times n plus 1. I multiply here itself. N times n is n square. 1 plus 2, 3n plus 2 times 1 is 2. This one. So further simplification, n plus 2 divided by n factorial, and the like terms I can simplify. Here n square is present. There is no other term containing n square. 3n and n. These two are like terms. So by adding 3n and n, I have 4n plus 2 plus 1 plus 1. This gives me 4. So it is very interesting here. The last expression we got here is a perfect square. N square plus 4n plus 4. It is n plus 2 whole square. So I can simplify and I can cancel this n square, n plus 2 with 1 n plus 2. So this is n plus 2 whole square. And n is not minus 2. If n is minus 2, then this n plus 2 becomes 0. So n cannot be minus 2. N starts from 1 onwards. So therefore I can cancel n plus 2 with this n plus 2. So then I have 1 by n factorial times n plus 2. So here the aim of writing this nth term in simplified form is, if I can get some terms with a by n factorial type and b by n plus 1 factorial type are in this way, are with minus sign, so that by adding these terms one after the other, giving the value of n from 1 to 2025, some terms alternatively positive and negative may get cancelled. That is the idea I have. But here by seeing it, this is how to write this product which is in the denominator, and it is in the type 1 by some number into some number, and I have to write it in the form of a by a number minus b by a number type. So for this one, uh, so what I want is, I want n plus 2 here, and n plus 2 should remain. To get this n plus 2, so suppose I write n plus 2 factorial here. Actually n plus 2 it is. And if I write n plus 2 factorial, then what I have to do? I have to multiply numerator also by n plus 1 factorial. When I get n plus 2 factorial here, n plus 2 factorial I get, if I multiply n plus 2 by n plus 1 factorial, then I get n plus 2 factorial. This is the idea I have. And now that means I have multiplied the denominator by n plus 1 factorial. So at the same time I have to multiply this numerator also by n plus 1 factorial. So now multiplying both numerator and denominator by n plus 1 factorial and n plus 1 factorial, I got this one. N plus 1 factorial divided by n factorial times n plus 2 factorial. And at this stage, if I think what can I do here, how can I split it, still not so useful. So okay, all right, n plus 1 factorial as n plus 1 times n factorial. Now it is useful for me. So n factorial times n plus 2 factorial. So here I can cancel it. N factorial I can cancel. Now at this stage, how can I write it? I can write this, and here if I write n by n plus 2 factorial plus 1 by n plus 2 factorial, and if I use sigma n is equal to 1 to 2023 I have to use, so then no term get cancels because here plus is present in the two terms, between two terms. So I want minus term. So to get a minus term here, what I do is I just write 2 in the place of 1. That means I have to subtract 1 also. That is, 1 is added and 1 is subtracted. So divided by n plus 2 factorial. So okay. Now I make this n plus 2 a group and minus 1 another group. So separating n plus 2 by n plus 2 factorial minus 1 by n plus 2 factorial. So really it is very useful. N plus 2, we can cancel n plus 2, and here I get 1 by n plus 1 factorial. So 1 by n plus 1 factorial minus 1 by n plus 2 factorial. This is our nth term. So now using this nth term, I can get the sum, the required sum. It is very easy to get it. How? Just I can take the sum for this nth term an, and n should be varied from 1 to 2023. So then I get the answer for this. So okay. Now, now taking the complete summation an, where n is equal to 1 to 2023. So here I get 1 by n plus 1, that is 2 factorial, minus 1 by, when n is 1, this is 3 factorial. This is the first term. And the second term is when n is equal to 2, at 1 by 2 plus 1, 3 factorial minus 1 by 4 factorial. And the next third term in the given expression becomes 1 by 4 factorial minus 1 by 5 factorial, and so on. This should be continued up to 1 by n is 2023. So then I get here 2024 factorial, that is n plus 1, minus 1 by n plus 2 is 2025 factorial. So finally what I get? So here we can see this minus 1 by 3, this is plus 1 by 3, of course with factorial, minus 1 by 3 factorial plus 1 by 3 factorial, minus 1 by 4 factorial plus 1 by 4 factorial. So that means these terms, minus 1 by 3 plus 1 by 3 with factorial, this minus of 1 by 4 factorial plus 1 by 4 factorial, these terms I can cancel. And before this, the terms I got are 1 by 2023 factorial minus 1 by 2024 factorial. This 1 by 2024 factorial is also cancelled. Only two terms are left here. The two terms are, so 1 by 2 factorial, which is 1 by 2, minus 1 by 2025 factorial. Imagine it. Try to get the value of 2025 factorial. 2025 factorial. When the number increases, the factorial value of the number rapidly increases. 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, and 6 factorial is 720. See how rapidly the value of factorial is increasing when one natural number is increased. So here 2025 factorial is a very big number, and 1 by a very large number becomes a very small number nearer to 0. So this value is almost 0. That means 1 by 2 minus a number which is very nearer to 0 is approximately 1 by 2. This is the simplified answer of the given problem. If you like this solution, please subscribe to my channel. Thank you for watching.